And welcome to the Daily Space Weather. We've got the sun in multiple wavelengths and all kinds of other fascinating stuff. Coronal mass ejection kicking off here in the imagery. There's currently one unfolding. It looks like it'll be off to the northwest of Earth. If I had to guess, which I don't, this is the sun in 304 and 335 angstroms from the Solar Dynamics Observatory. We've got some filamentary behavior here, some great absorption features in those wavelengths up in the northeastern limb. There's 171 angstroms. Classic filamentary dance there. Now this is the colorized magnetogram since December 1st, so we put up about 3 days here of colorized magnetogram. Most likely spot to see a solar flare would be out of this sunspot group here. 2902 is the name of that. 2902. And we've got a new region rising down here as well. So this is actually a sunspot already. We've got some beta class sunspot active regions there just setting in the southwest. You can see the CME happening here quite slowly here, really, in the 304 angstroms view. Coronal holes are really the story of the day. So lots of stuff going on. Some large earthquakes came in as well. We'll get to it in a minute. The radio flux has been low here. I think it's only at 86. There's the 1 year chart. The black line is the 10.7 centimeter radio flux. 87 is the current radio flux according to the Space Weather Enthusiast dashboard. And we are expecting some upticks in geomagnetic activity as a result of coronal hole wind streams coming in. So we've just seeing one subside. We're seeing electron flux warnings, some large earthquakes. 2 6+ magnitudes came in the past few hours. There's the 90-day bar graph from volcanodiscovery.com. So what else do we have here? A deep quake at Japan, 4.6 magnitude, a 5.2 at Japan. Fiji saw a deep quake at extreme depth, 629 kilometers estimated depth there in the deep quake capital of the world, which is pretty much just this area. Anyway, those 6 magnitude quakes happened in South Sandwich Islands region and Easter Islands region, 2 very desolate parts of the planet, likely felt by nobody. There's another very deep quake at Fiji. Did I already cover that? There's a deep quake at Chile. That's 173 kilometers estimated depth. The 6.2 at Easter Island, around Easter Island, happened at 4:40 Universal Time today on the 3rd. The 6.0 happened at 8:33 Universal Time. So one south of the Atlantic Ocean there, around the Antarctic and South Atlantic plate boundary. The other happening between the Pacific and South American plate boundaries. Also a 5.5 at Tonga since then, so a pretty significant uptick there in seismic activity just in the past few hours. By the way, if you don't follow us on Twitter, check us out over there at twitter.com/smAsho. We put up all kinds of space weather stuff that is exclusive to retweets and so on. You may ask for more cowbell. We're asking for more coronagraphs. So perhaps read that interesting article. Perhaps we'll cover that in the future, especially when the thing actually launches. Let's check the most recent volcanic activity. La Palma continues to explode. Flight level now 070. Karimsky, 8,000-foot ash plume as Karimsky explodes, so that's now back on the list. An eruption on the Kamchatka Peninsula, Russia. Suwanosejima exploding, 7,000-foot ash plume from Suwanosejima. It's located in the Ryukyu Islands. Fuego in Guatemala exploding, flight level 150. Nevado del Ruiz exploding. 21,000-foot ash plume over Colombia, flight level 210. Sangay exploding, flight level 200. Sangay and Revenador both located in Ecuador. Revenador is also exploding. 16,000-foot ash plume from Revenador. Intermittent emissions from Saab and Kaya. Not sure the size of the ash plume there. Don't fly your hang glider or John Denver-style ultralight aircraft over the caldera. Nevado State Chilean, don't square dance the caldera. We're unable to detect whether or not it's erupting. Don't pole vault the caldera or any calderas, please. We need the views on YouTube. Today's featured product is the Do Not Pole Vault the Caldera socks. I'm wearing them. I won't try to put them on camera, as they will not obey the color keying that allow my face to blend into space. Anyway, if you're going through hell, keep going. Do not pole vault the caldera. Do visit the links. You can find links below the video to all kinds of other websites, such as our homepage, smAsho.com. You can find the Redbubble shop at the smAsho merch link. Also, thanks to the Smash team. A new article there about stellar evolution and a new type of star that you may want to read. smAsho.com/Smash team. For all you magnetic personalities out there, here's the magnetic data. So the GOES magnetometers have just diverged here. We see higher readings coming in on the GOES 16 and lower readings coming in on the GOES 17. For you new viewers out there, the N's and M's, they mean noon and midnight. Those red letters are for the GOES 16. They're geosynchronous satellites located near the equator. Next, the heliospheric current sheet polarity imagery, part of the Gong 2 data that we show daily. It's from the National Sunspot Observatory. And this is one of the most important visualizations that we can do as far as solar forecasting. You can see a South Pole current sheet rushing our way. At the moment, we could snap across here more quickly than you may expect, although I think it's going to be a long delay. I expect the Earth to remain in a North Pole current sheet when we do tomorrow's video. That red area, that's the South Pole current sheet. I expect it to be waiting at least another day to show up. I won't explain the magnetohydrodynamics because it's a daily space weather video. We don't want it to be too long. That's for a cosmology segment, I guess. There's a line of sight view of the same data. Essentially, it also shows the solar magnetogram. Note the sunspot rising in the southeast. Coronal holes, again, they are the main story here, as there are a lot of protons coming out of that North Pole-oriented coronal hole, and some of them are headed directly toward you. We've also got some South Pole systems here moving through. We'll be waiting to get a better view of those. We put up a composite today instead of just 193 angstroms. This is 193 and 211 to show even greater depth of that massive coronal hole system. You can also see the coronal mass ejection propagating there just to the northwest of that coronal hole. Again, likelihood of major flares isn't really that high. I mean, we wouldn't be surprised to see maybe a C-class flare or maybe even an M-class flare here at this moment, since we've got these. It looks like they're both showing up as alpha-class sunspot groups, but 2902 still has complex fields. This new rising region appears to be an alpha-class sunspot, at least when I did show prep. Let's continue on to see the flaring profile the past 3 days. No interesting solar flares at all. Low levels of solar activity in general, including the radio flux and so on. No spikes in the proton flux, those relativistic particles typically associated with solar flares. Let's go to the real-time solar wind, which has been quite consistent here over the past 24 hours. Fairly unremarkable. A high-speed solar wind stream is waning. Current solar wind velocity 445 kilometers a second. Solar wind density just over 9 protons per cubic centimeter. Fairly unremarkable. Geomagnetism at a KP1. KP index. And next, magnetohydrodynamic pressure. Let's bring this back. The space weather modeling framework here. Expecting somewhat homogeneous pressure here over the past 4 hours, which is what is typically shown in these videos. And it's refreshed. Let's just let it play through. We don't edit the videos. We keep them raw Shout out to the Wu-Tang Clan. And you see a little increase in pressure there, followed by a little decrease in pressure. Nothing to write home about, at least in the past 4 hours. Next, ground magnetic perturbations, changes to Earth's B field here at the ground level. We showed you the magnetic moment from space. Here's the magnetic moment on the surface of the planet. This is great at showing you where the most likely places for Aurora Borealis, Australis, and high induced current in your electrical grid would be located. Nothing to write home about there. Here's where planets are located. If you're frightened of planets, please take a physics class or something. Don't be frightened of planets, folks. And we're approaching a new moon. We hope you're all sleeping. We hope you're all doing great, especially those reverse werewolves out there. So shout out to all the reverse werewolves who sleep well and are generally good people and don't eat others. And they sleep at night and do productive things in the daytime. Reverse werewolves, shout out to all of you. Let's do a forecast. And there's where things will be in a week. It's a crescent waxing. Here's a star chart if you're interested in making one for yourself. Head to in-the-sky.org. I like it. That's what's going on above my head in Lehigh Valley, Pennsylvania. The yellow line is the ecliptic. The blue line is the galactic plane. Next, we're going to show you the coronal mass ejection. It's not really a warning. There's just one happening at the moment. We're not trying to forecast it. We put the word watch in our title and video yesterday. And you probably didn't see it because the number of views on yesterday's space weather video was pathetic. I think it's at, let's see where it currently is. It's at 69 views. One of the most pathetic viewerships of our daily space weather videos in quite a while, actually. Anyway, the coronagraphs aren't really showing anything, but there is a CME happening at the moment. It's some old data. Let's see if we can see anything on the difference imagery. Again, there is a CME happening as we make the video. So there should be something showing up here, but nope, it's still old data. So we'll just move on to a cosmology segment. And don't forget to look at the playlists if you're interested in cosmology. As I've been interested in cosmology for quite a while, and some of the weirder theories seem to be coming true. So it's pretty windy here near the galactic core. Let's do our cosmology segment. Today's random number is 21. I decided to go with that because it's the number of one of my favorite basketball players of all time, Dominique Wilkins. Shout out to Neek Wilkins. If you're viewing the video, drop us a line. We'll interview and talk about space weather. Today's featured object is number 21 at the Neil Gehrels Swift Bat X-ray Observatory. It's Quasar B0048-09, a BL Lacertae object, a type of active galactic nucleus. It's a distant galaxy. There's the X-ray emissions from it. And here it is in the optical spectrum from Pan-STARRS bands D and Z, I believe. And that's just a galaxy. It could be an elliptical galaxy. It's not really clear because its jet obscures it perhaps a bit. Here it is in infrared. And a great view there from the 2 mass, that active galactic nucleus. Again, Quasar B0048-09. It's a galaxy. Speaking of galaxies, check it out. Is this galaxy blasting this other galaxy? Nope. That's Comet Leonard, which is in the foreground. And that's another galaxy, which is also in the background. And that's the astronomy picture of the day. You can go look at it yourself at apod.nasa.gov. That makes a great desktop. Perhaps we'll even have to make it as part of today's thumbnail. Next, let's talk about cosmic rays. They're becoming increasingly important to things like the climate, the sun's activity, If you want to find the site that we use to find our cosmic ray data, do a DuckDuckGo search for links to cosmic ray data. You'll find this Russian site, and that's where we found these reliable stations. So the stations that we look at them for a reason. They're well curated. They have legit looking data. They're not full of crap, and that's why we use them. So the Opacity Neutron Monitor, for example, been looking at it for a few years now, and you can see the last 30 days here. Relatively flat, except for this major downtick, which was associated with a solar flare, a coronal mass ejection, and relativistic protons. Making it to Earth, yes. Next, Barentsburg. A clear relationship between solar activity and cosmic ray flux. Barentsburg slightly downticked there over the past 30. Opacity pretty flat over the past 30 days, not really figuring in that solar activity. Next, we're going to go farther south to Athens, Greece, to see that their site is down. We hope that gets fixed. Hopefully it's not under lava. Next, Mexico City. You can see pretty flat there at Mexico City over the past 30 days in cosmic ray flux. Next, Oulu, Finland. Going back north, really far north, and then as far south as you can get to Antarctica. There's Oulu. Over the past 60 years, as well as the past 30 days and the past 24 hours. Pretty flat there over the past 30 days. DOMB Antarctica. And we just saw a big spike there at DOMB Antarctica. Just in the past few hours, actually. Happening midday, a little before midday Universal Time yesterday. And DOMC Antarctica not showing that same spike. And of course, different spots on the planet have a different cosmic ray flux profile. Perhaps it tells us something about the internal workings of planet Earth. That's today's cosmology segment. Remember, folks, geophysics may be in the process of being rewritten if we discover that stars are not made of gaseous plasmas. Of course, the outer part is made of gaseous plasmas. And if you enjoy the content, press like and subscribe. Again, don't forget to check out the playlists, youtube.com/smashamash/playlists. YouTube's not going to recommend our videos to you. You have to go find them yourself. We've got some charging hazards. And high levels of electron flux can charge up satellites. You can see this is where those equatorial geosynchronous satellites are located, and there is some charging possibilities there over places like the southern Indian Ocean and Oceania there. Parts of Australia may see charging hazards overhead. There's the 1-year chart of the greater than 2 mega electron volt electron flux. Here it is over the past 3 days. That's greater than or equal to 2 mega electron volts measured by the GOES 16 and 17. And we've gone into warning territory here for the GOES 16, but not the GOES 17. Here's the forecast, and NOAA's forecasting a further increase. So you can expect to see an increase there in the GOES 17, I would say. No arguments with that model. There's a lot of things happening it's not worth being concerned about. Next, the total electron content forecast. Essentially looking at the electron content of the inner Van Allen belt. Here is the total electron content forecast. So there, we do expect to see some GPS errors in some odd locations here, as we typically do when we have high levels of electron flux. Nope, not really. Everything's pretty organized at the moment. So a little bit less GPS error is likely today than yesterday. And I think I said that backwards. We typically see more chaos in the total electron content during coronal hole wind streams while we have low levels of electron flux. The electrons get less organized. So no major anomalies there in the total electron content forecast. Next, we're going to show you the ionosphere, the F layer. So here's the F ionosphere in vibrational frequency as reported by the Australian Government Bureau of Meteorology. And you may not be familiar with this map. There are a whole bunch of different views you can look at here and all kinds of other interesting features as well on these sites. We show the ionosphere and the anomaly map. So this is the ionogram, and then here's the anomaly in megahertz from the 30-day median. Low-frequency anomalies over places like Africa. Quite a bit of low-frequency anomalies here. Anyway, here's the latest image. That's 11:30 Universal Time ionogram. And there's the 11:30 Universal Time anomalygram. Again, anomaly in megahertz from the 30-day median. And it's time to do bonus features. It is windy here at the Galactic Core, I gotta say. Do you watch our meteorology segments? They are totally sweet. We just typically premiere them before the daily space weather videos, so check those out. There's a playlist for it. And let's move into our bonus features. So here is the Cerro Tololo, Chile ground-based solar observatory. Let's blow it up, as there is probably going to be a CME visible here. This filament right up here should be releasing. And you can see in the last images there, it's not showing up. Probably some clouds over Cerro Tololo at the moment. Let's not worry about it. Here's the NASA GO 16 SUVI, and you can see that filament perhaps collapsing back onto the corona, but it certainly looks like it's ejecting to me, and it certainly looks like it's headed to the northwest. So we didn't really have time to make that into a coronal mass ejection warning. I just wasn't watching that closely, to be honest, which I am constantly. So you can see those sunspots setting, they're going to lose their name today. This one is the most likely spot for significant solar flares. And this one rising down here is only an alpha class. So you can see there's only one polarity umbra there. That's the most likely place to see a significant flare. Sunspot 2902. Here's some more imagery of this filament in the northeast. And we'll close out on a close-up of this massive coronal hole, which will be the story of the geomagnetic unrest, storm, whatever, aurora borealis, incoming solar protons from a high-speed coronal hole wind stream in a couple of days here. A couple to a few days, I should say, for all you pedantic viewers. And thanks for paying attention to all the details. We certainly do as well. Once again, thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name it news.